In this question, we're given the curve y equals 1/2 x squared plus 4x plus 6, and we're going to state 5 points on the curve, and then we're going to graph it. Well, this curve is not given to us in vertex form. It's given to us in standard form. So our first job is going to be to get it into vertex form. I'm going to use the process of partial factoring to do that. So we have y equals 1/2 x squared plus 4x plus 6. Partial factoring means we have 1/2 x times x plus 8. Okay, 1/2 x times x plus 8 equals 1/2 x squared plus 4x. And then we still have the 6 added on the end. Now, if I let this factor equal 0, I get x equals 0. And if I let this equal 0, I get x equals -8. So partial factoring is going to tell us that x equals 0 and x equals -8 represent lines that are equidistant from the axis of symmetry. So in other words, the axis of symmetry will be halfway in between these two. And the axis of symmetry will be at x equals -4. Okay, so there's our axis of symmetry. Now at x equals -4, the y value, when you plug in a y value of -4, we get a y value of -2. So what happens is we can say that the function that we were given is actually 1/2 times x plus 4 squared minus 2. Alright, well that's useful information because we can now determine our a, h, and k values. A is 1/2, h is -4, and k is -2. Remember, a is this value. Now, we always put in the bracket x minus h. So x plus 4 is like saying x minus -4. So the h value is -4. And finally the k value is -2. Now what we then do is we start with the 5 key points on the parent function y equals x squared. Now those 5 key points are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. These 5 key points are on the parent function y equals x squared. Well, what we're going to do is transform each of the points. So we take -2, 4. We're going to multiply the y coordinate by 1/2. Multiply the y coordinate by a. So 4 times 1/2 is 2. So -2, 4 becomes -2, 2. -1, 1, multiplying the y coordinate by 1/2 becomes -1, 1/2. Multiplying the y coordinate by 1/2 is 0, 0, stays 0, 0. 1, 1 becomes 1, 1/2, and 2, 4 becomes 2, 2. So notice that in this first stage, all the x values remain the same, but all the y values were changed. Okay, we multiplied every y value by 1/2. Actually, the 0 wasn't changed, but we multiplied all the y values by 1/2. Now, that was the vertical stretch portion, and also, had there been a reflection in the x-axis, this step would have accounted for that as well. Now we're going to deal with the translation portions. So what we do is we add, the way I've written it here, add hk. We're going to add the h value to all the x coordinates and the k value to all the y coordinates. Well, the h value is -4 and the k value is -2. So -2 plus -4 is -6. 2 plus -2 is 0. So this point moves to here. Similarly, the point -1, 1/2 will move to -1 plus -4, which is -5, and 1/2 plus -2, which is -1 1/2. 0, 0 will move to 0 plus -4, and 0 plus -2. 1, 1/2 will move to 1 plus -4, and 1/2 plus -2. We get -3, -1 1/2. And finally, 2, 2 will move to 2 plus -4, which is -2, and 2 plus -2, which is 0. And we've now got 5 points on the parabola. So all we have to do is graph these 5 points. Okay? Well, there they are. The 5 points we just had written down here are these 5 points right here. And now we've got our vertex Our vertex is our point in the middle here, our low one, and we're going to draw a parabola that goes through all those points. There we go. And there's our parabola. And seeing that makes me so happy that I turn it into a big smiley face.